Okay, so this is 11.6. This is the slides that we would start at the beginning of our lesson. And as I opened this up, I wondered, what are we trying to figure out here? And then I realized up here at the top, it's a title with nothing labeled there. So what I think it wants us to do is it wants us to interpret the data and to write a title up here. So if that's all we're supposed to do, then let's kind of consider what we're doing. We've got distance and we've got time. So this is how far and in how much time. How far and how long, I guess we can put it. Not the greatest of titles, but basically what we're asking is how far someone can go in a certain period of time. And down at the bottom, we have our minutes. So in 5 minutes, these points are marked with black dots. We can find some other points that are pretty close, but this point is marked on a black dot. So we can find what's on our x-axis in time and what's on our y-axis for distance. So I don't think this is 10. These are 10 lines before that. So let's find out. 1, 2, 3, 4, 5. Okay, so this number line going up and down, the y-axis, is broken up into chunks of 5. So how much would each one of these lines be equivalent to if my first number that I see here is after 5 lines, which is 10? So 2 goes into 10, 5 goes into 10 2 times. So each one of these lines equals 2 kilometers. 2, 4, 6. So this first dot represents 6 kilometers in 5 minutes. And if you were to consider how that might look if you're driving, it might look like this. 6 km, which is kilometers, per, it's a slash line, per 5 minutes. We're used to talking about miles, but we can kind of get the idea of 6 kilometers per 5 minutes. Now on to our step-in section on lesson 11.6. Open up your books to page 410, and we'll start. We're going to read what it tells us to do. A scout troop is organizing a weekend camping trip. The grid below shows the number of cars needed to transport the scouts to camp. So, for every one vehicle, there are 4 kids. So, how many kids would we take if we had 2 vehicles? Well, we can kind of figure that out if 1 and 4 are the first. And I'm going to guess that if we take and double the number of cars, that we can double the number of scouts. We have 1 times 2. Let's see if we take 2 times 4, if we come up with the right answer. So 2 cars and 4 and 8 scouts. If we had 3 cars, we could have 12 scouts. If we had 5 cars, we could have 20. And let's see if to figure this out, we're saying number of cars times the number 4. If we were to have 10 cars, then we're off the chart already, but we can figure out how many cars or how many scouts we could have with 10 cars. We take 10 times 4, and we come up with the number of scouts that we can take on this trip. There are a total of 40 scouts that can go on a trip if there are 10 cars available. So the grid below here shows how many cups of water is estimated each scout will drink each day. Now, don't think of it as a cup like we would drink out of. A cup is a unit of measurement. A cup is 8 ounces. So we're not going to think of it in terms of this type of a thing where we drink out of a cup. More than likely, it's going to be in some sort of a bottle, okay? And that will probably be the way you need to think of this one a little bit. So the grid shows how many cups of water it is estimated each scout will drink each day. So one scout, they're estimating, will drink, well, this many cups. Oh, how much does each one of these lines represent? Well, there's two lines between 0 and 12. So I can take the number 12 and divide that by 2. And I can realize that this first line, that's 6. So for scale, each one of these lines represents 6 cups. 6, 12, 18, 24, 30, and so on all the way up to 60. So if we have one scout, we will need 6 cups of water. If we have 3 scouts, we will need 18 cups of water. So depending on what we're asking, will help us understand what part of the chart we should look at to interpret this. If we could say this. If we had 24 scouts, we know that for every 1 car, we can have 4 scouts. Let's divide the number of scouts by 4 to see how many cars we would need. We should need 24 divided by 4 is 6. So we should need 6 cars. Does that look like that continues the line like we would expect it to? It does. So number of scouts equals how many cups of water. If we happen to have 10 scouts, how many cups of water would we need? Well, 1 scout equals 6 ounces. And we could look at that and say 1 times 6 equals 6. If we had 10 scouts, how many cups of water would we need? We'd take 10 times this 6 to get 60 cups, excuse me. Erase that, and right in there, cups. Each cup is a certain number of ounces that we don't need to worry about right now. How many cups of water will 6 scouts drink? We look at our chart that talks about the amount of water. 6 scouts, we go up, and we can kind of take a ruler, we can kind of draw a line connecting these points and then continuing it on up to discover as far up along the chart as we can. But if we had 6 scouts, we would need 36 cups. And we're just following this as if we drew a line on there. You guys can actually draw a line. How many scouts can be catered for with 18 cups of water? If that's all we had, how many scouts could we take? Find 18 cups. There's our number of scouts we have. We would be able to take 3 scouts. How many scouts can be transported? By 5 cars. Look at our chart that talks about cars. So let's see, if we have 5 cars, let's go across. Oh, we can carry 20 scouts with us because each car we know can take 4 kids, 4 scouts. How many cars will be needed to transport 17 scouts? Well, 17's not on this, so we're going to need to figure out what's our formula. So 4 goes into each one of these 1 cars. So let's think. What we've done is we're dividing the number 4 into each one of these numbers here. So if we had 4 kids, we divide by 4, we get 1 car. If we have 8 scouts, and we divide that by 4, we get 8 divided by 4 gives us 2. So this is an uneven number, not going to come out equally. So we've got 17 scouts. We're going to divide the number 4 into that. So 4 goes into 17, a full total of 4 times. We have a 16, and then we've got our remainder. So we've got 1 scout, 1 kid that won't be able to go if we only take 4 cars. But it asks us, how many cars will be needed to transport 17 scouts? We've got 17 going on this trip. For 17 scouts, we're going to need 5 cars. Does it make sense to draw a line to connect the points in the grid? I think it can. Now, I'll warn you, my line is not going to be straight where I'm doing it like I am. Ooh, there it goes. let's see the step up. Look at the grid. So we've got all the work we need up above. Look at the grid that shows the relationship between number of cars and scouts. Record the ordered pair for each that is shown in the grid. So we go back. What's our X and what's our Y? When we put together ordered pair, we put them together in order of X, comma, Y. Notice I also have to include parentheses. I'll do 1 for you. So we'll do 1 here, the very first one. We're going to do only the green dots, by the way. We've got 4, comma, 1. Parentheses, 4, comma, 1, parentheses. Now I want you to come up with all of the ordered pairs that are shown on the grid. Second one, look at the grid that shows the relationship between number of cups of water and scouts. Record the ordered pair for each point that is shown on the grid. Same thing. Here's our X and here's our Y. X always comes first. So I'll do 1 for an example again. We'll start with the very first one that we see in this grid. We see a number 1 across from a number 6. I'm glad that I wrote in some of those numbers already. So my ordered pair looks like this: 1, comma, 6. Not a period, a comma. Now let's take a quick look at the next page. Oh, number 3, a plane moves at a constant speed in a straight line from a starting point. The grid on the right shows the distance from the start at points in time. So we have kilometers and we have amount of time. So every 10 seconds, it's going 2 kilometers. I don't know if that's fast or not for a plane. So record the ordered pair for each. Oops. Do we need straight line? Let's go ahead and use your ruler or some sort of a straight edge, maybe a book where you can draw a line. Start here and go all the way through. Just keep going all the way up until you get somewhere up here, okay? Record the ordered pair for each of the points shown. So we've got 3 ordered pairs. X, comma, Y. Mark the point to show the distance at 50 seconds. Here's 50 seconds. And if you drew that straight line, you'll be able to find at what point, how far they've gone in 50 seconds. How far will the plane travel after traveling 15 seconds? You'll have to look at the chart and find where 15 would be. How far will the plane have traveled in 15 seconds? How long will the plane have traveled to reach 9 kilometers? Wow, you're going to have to decide where 9 is, and then go across and see if you can match the line up to a number below. And I think that the next set should be really similar. It asks us to record the ordered pairs in a table, actually, too. So you're recording them in this chart, X and Y, and then you put those X and Ys down here. It looks like record the ordered pairs in this table is all you're going to do. Step ahead, like yesterday, I'll be looking to see how you did on the step ahead and may record a video about that as well.